We often treat the human brain like a computer hard drive, assuming that by the time we reach adulthood, our biological circuitry is permanently locked in, setting a rigid limit on our skills and potential. But specific biological anomalies contradict this. Stroke patients sometimes describe a third arm growing across their torso, and amputees often feel the vivid sensation of water trickling down a limb that was surgically removed years prior. These experiences originate as physical glitches within the actual tissue of the brain. This happens because of the somatosensory strip, a thin band of tissue across the brain's surface that acts as a literal spatial map. Every body part has a designated physical territory here, etched directly into the cortex. Our physical reality follows the boundaries of this internal map, which constantly redraws itself through heavy unlearning, the principle that cells which fire together wire together. Repetitive physical action forces the brain to allocate more biological real estate to the body parts in use. Brain scans of blind Braille readers provide the proof. The specific finger used to read commands a significantly larger territory on the brain's map than the non-reading fingers on the same hand. When physical borders change, the map adapts. Consider children born with webbed fingers. Because their fingers always move as a single unit, their brain map treats the entire hand as one blurred, continuous territory. Once surgeons separate those fingers, the brain responds within weeks. That single blurred territory divides, carving out distinct individual territories for each newly freed finger. Constant sensory input and physical experience act as editors for this internal cartography, proving that our anatomy does not strictly dictate our brain structure. This redrawing process doesn't even require physical movement. Focused mental imagination can trigger the exact same mechanics. One 400-meter hurdler mentally rehearsed his race from an armchair with such intensity that he physically exhausted himself. His heart rate and breathing increased in direct proportion to his imagined speed. Elite athletes like javelin thrower Steve Backley use this biological overlap to stay in peak condition. When injury prevents physical practice, they maintain the neural connections of their skills through pure mental simulation. The clinical evidence is striking. Volunteers who merely imagined a 5-finger piano sequence for 2 hours a day showed the same physical expansion in their movement control brain areas as those who actually practiced on a physical piano. For the brain's internal map, the boundary between a physical action and a focused mental image is remarkably fluid. But the map can also become a source of chaos. Studies of soldiers from the Yom Kippur War revealed that even when a limb is violently removed, the internal map representing that limb often survives. This leads to neural theft. Face neurons sit right next to the hand territory. Starved for input, these face neurons invade the vacant hand area, creating physical cross-wiring. Touching the amputee's actual face sends signals through those stolen circuits, causing vivid sensation on missing fingers. This confusion often traps amputees in agonizing pain. Without feedback from a physical limb, the brain can lock the phantom hand into a permanent, painful spasm, with ghostly fingernails digging into a palm that no longer exists. These phantoms are the result of an active, hungry brain map trying to function without its physical territory. This creates a unique medical challenge. How do you treat a painfully clenched fist that only exists inside locked neural circuits? Doctors use a mirror box to bridge this gap. By placing the intact arm inside, the patient sees a reflection that creates a perfect visual illusion of two healthy, functioning limbs. As the patient unclenches their healthy hand, their eyes feed specific visual data to the brain, providing the first evidence in years that the cramped phantom hand is actually opening. This new visual feedback overrides the stubborn neural circuits, instantly redrawing the map and releasing the phantom pain. If a simple visual illusion can rewrite a broken brain map, then the habits and thoughts we repeat every day have enormous influence over our biological structure. Every practiced skill and focused thought turns us into the active cartographers of our own minds.